So let's attempt to solve this oblique triangle. This oblique triangle, we are given one of the two options that we must use a law of cosines. Either where we have a side, 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 all three sides are known, or a side, angle, side, where I have a side, an angle, and a side, and those are known. That's the particular case on this one. So we have a side, angle, side, oblique triangle, and we will need to use the law of cosines to begin to help us solve this particular triangle. B and C are known, and the cosine or angle A. So I'm going to look at that original one, which is A squared. So A squared equals B squared plus C squared minus 2 times B times C times the cosine of A. B is 20, so 20 squared plus C squared, which is 30 squared, minus 2 times B times C times the cosine of 60. Let's see what that equals. I have to do this in a couple steps, it looks like. 20 squared plus 30 squared. 20 squared is 400. 400 plus 900 gives me 1300. Minus 2 times 20 times 30 times cosine of 60 equals 600. So A squared equals 700. A equals 7, or the root 700. So now we have the distance for A, or the length of A. From there, we can now use the law of sines because we have a couple of ratios that are active for us. And so I know A, and what we're trying to solve is, let's solve for B since we have the side opposite that one. So A over the sine of A equals B over the sine of B. A is root, and we're solving for sine of B in this particular case, so let's just rewrite that as a solve first. Sine of B equals B times the sine of A all over A. B is 20. Sine of A, 60 degrees, which we know, divide by A, which is root 700. All right, and root 700 is approximately 26.5. All right, let's see what we got here, folks. 20 times sine of 60 divided by root of 700 equals 0.6. So sine of B equals 0.6546, 0.65. I'll go 0.65. We know there's two angles that are involved with that. And so let's solve for sine of B. So take inverse sine. And that equals 40.54 degrees. So B equals 40.5. And the other one, 0.65, 40 degrees, 180 minus that is 140 degrees, 139. Cannot use that one because I already have a 60 degree there. Those two combine beyond 160. So I know I only have one angle I'm looking at. So this one has to be 40.5. Notice I have all the sides now, all the sides solved and 3 the angles solved. So my third step in the process is just use the interior angles. 60 plus 40 plus this should equal 180. So that's 79.5. Let's write it better, 79, because we're excited that we got it. So using the law of cosines to solve an oblique triangle looked like a three-step process. Step 1, use the law of cosine. Step 2, use the law of sines. Step 3, use the understanding that interior angles add up to 180 degrees. And there we solved a side angle side oblique triangle. We have a side oblique triangle. Our three-step process is 1, use the law of cosines to help us find an angle, then use a law of sines to find next information, and then interior angles to round off the end. The first thing we'll do is we're going to look for the angle of B because we want to use a law of cosines on the angle opposite the longest side. So that's being the case, then we're going to use the second feature right there, which says B squared equals A squared plus C squared minus 2 times A times C times the cosine of B. Solve that for the cosine of B. So let's do some work here for a second. B squared minus A squared minus C squared equals negative 2 times A times C times the cosine of B. Divide both sides by negative 2AC. Doing so, now I have just a cosine of B by itself, and I'm just going to write cosine of B first, equals B squared minus A squared minus C squared, all over negative times 2AC. Plug in our values that we have here. B squared is 81, minus A squared, 36, minus C squared, 16, all over negative 2 times A, 6, times C, 4. 81 minus 36 minus 16, 45, 29. In the numerator, and in the denominator, 2 times 24, which is 48, so a minus of 48. So I'm going to look for the cosine of B at 29.48. And so that's the inverse. So let's figure out the inverse cosine of that. That produces an angle of 52. 53, we'll make it 52.8. Let's make it 53 degrees. So that's what B equals. I notice it's negative, and so that produces it in the second quadrant, which means then that I have an obtuse angle. So that obtuse angle then would be 180 minus the 53 degrees equals 137 degrees. So B, angle B equals 137 degrees. And there's my obtuse angle. From there, we can now use one of the law of sines. And since I'm looking for A and I have B's, let's go ahead and do that. So A over sine of A equals B over sine of B. And I'm looking for the sine of A since I don't know that. And so A is 6. Sine of B, 137 degrees. Divide by B, which is a 9. And that'll produce the sine of A. .45. So sine of A equals 0.45. Let's take the inverse sine of that. Inverse sine of 0.45 equals 26.7, or roughly 28 degrees. And so my angle there of A is 28 degrees. The other option would have been 180 minus 28, which would produce 150, way too much degrees for this particular triangle. And then from there, step 3 is interior angles add up to 180, so 28 plus 137 plus C equals 180. 28 and 137 is what, folks? 165 plus 15. So the last one had to be 15 degrees. So there we were able to do a 3-step process using the law of cosines to solve a side. Law of cosines first, find the side opposite the longest side, or the angle of the opposite of the longest side. Use the law of sines, and then the interior angles to round out the rest. I noticed I made a mistake, and you guys should probably keep along as well. The mistake came from the easiest part of it. I can't do my subtraction right, can I? 180 minus 53, 127, Willie. And then I use that 127 degrees over in my law of sines. So I need to go back and redo that. So this is 127 right there. So let's redo that again. Equals 0.53. Inverse sine of that then equals 32 degrees, or 180 minus 32 degrees, which is too many degrees for this triangle, so it has to be to 32. And there to find a C then, it's 127 plus 32 plus C equals 180. 127 plus 32 is 159 plus C equals 180. And that to be true is 21. So it equals 21 degrees. And 28 is not 28, but 32 degrees. How about that? All right, made a mistake, but we were able to identify it, go back and see where that mistake occurred. I know you guys love doing it where you make a mistake early on in the problem to do everything else correctly off of that mistake. That's what I did, but that's all right. We all make mistakes. That's what math is about, is learning. Went back through, corrected my mistake, and went from there.